Okay guys, so in this video we're going to be talking about radian measure of an angle. Before we talked about degrees, and the way we define degrees is that we took a full circle and we divided it into small our pieces, like so this would be our starting point, 0 degrees, and then we divided our circumference in 360 equal portions, and we called one portion, the angle that cuts out this one portion, is 1 degree. Okay, so that's how we defined our degrees. Of course, it's smaller than what I'm showing here. And a quarter circle was 90 degrees, so there was 90 little ticks here. And then a half a circle would be 180. Two-thirds, no, 3/4 of a circle is 270 degrees, and the full circle around is 360s. Okay, so that's how we defined degrees. And of course, there are other very important angles that we're going to be talking about in this class. One of them is 1/8 of a circle is 45 degrees, and then 1, 2, 3/8, it's 90 plus 45, that would be 135 degrees. And then 1, 2, 3, 4, 5/8 is 225, and then plus another 2/8, that's plus 90, and it gives me 315 degrees. So those are important. We also have a third and 2/3 of 90. So 1/3 of 90 is 30, 2/3 of 90 is 60. And then we have all of these like thirds all around the circle as well. Those are also very important measures, and we are going to be talking about them a little later. But today, I want to show you a different system of measuring angles. It's not better, it's not worse, it's just different, or defining angle measure. And this type of angle measure uses a radius of a circle as a reference. And that's very convenient, and I'll show you why in a minute. So if we took a piece of string that is exactly the same size as radius, and cut it out, and then if we tried to wrap it around the circle. Okay, so here's the piece of string, and now I'm trying to wrap around the circle. Well, it so here we go. This would be the point. If we draw a ray through that point, the angle that will be cut out is said to be have a measure of 1 radian. So this is how the radians were defined. We looked at the circle's radius, and this piece of circumference that equals to the radius would give you an angle of 1 radian. And this is very convenient because now the measure of the angle is tied to circumference of a circle. And by the way, a piece of circumference of a circle is called an arc. That's how arc is defined. It's a piece of circumference cut out by a central angle. So How many radians are there in a circle? Well, if we put, and well, let's talk about again the connection between the um, angle and the arc. So so this was 1 radian. If I put another piece of the same, equivalent to the radius of the circle on the arc, this is going to be another radian. So now this angle is 2 radians, right? And so forth. Um, Now, it turns out that let's do one more. In half of a circle, there's almost 3 radians. Almost 3, but not exactly 3. So half a circle is right here is actually approximately 3.14 radians. It's actually an approximation because in reality, this number is going to be an infinite decimal, but it is approximately at 3.14, which is, we call it pi. This is one very famous, widely used irrational number, pi. Okay, and this is the number of radians in half a circle. Again, that's how it's defined. There's nothing magical about that number. That's mathematicians were measuring how many radians can we fit into half circle. Okay, and we call that number pi. So uh, the full circle around, there will be a little bit more than 6 radians. Okay, so 6 would be here. So this is 1 radian. This is 2, 3, 4, 5, 6 is right here. And this little piece is about, again, not exactly, but it's rounded, but about 0.28. So the full circle around, if half a circle around is pi, then the full circle around is 2 pi. Okay, so this is the basics of radian measure. Let's continue. Well, this is what we just mentioned. If the angle of 1 radian cuts out an arc of same to 1 radius, then 2 radians cuts out an arc of 2 radiuses. So that's actually, this is a very, very important correlation between the arc length and the radius, the arc length that the angle cuts out. So actually, to figure out the arc length is denoted by letter S. So it's the angle times the radius of the circle. So that's the direct correlation between the arc length cut out by an angle and the angle measure itself. So whenever angle is in radians, this correlation, this formula works. But okay, you may think, okay, what about, but not all circles have the same radius, right? Some of them are going to be smaller. Is it still work? And the answer is yes. So I want you to look at this picture. And in this picture, we have two circles and of different radii. So the first circle has a radius of 2, the inner one, and the outer one has a radius of 3. Okay, and we have one same angle shown here. It's not written in radians, actually, just 45 degrees. And okay, so this circle has a smaller radius, but so this arc is smaller as well. The outer circle has a longer radius, and the arc that's cut out is also longer. So they're proportional. Okay, so if the radius is smaller, one radian cuts a smaller arc. If the radius is greater, one radian cuts a bigger arc, a greater arc. So it's kind of like, if you look at them, sort of like similar triangles, right? Uh, similar triangles. So that relationship works here as well. By the way, since, and this is all that I want you to take out of this slide. Okay, there's I'm not going to get into um, other details, although we could talk about the fact that the half a circle is pi, right? And then a quarter of a circle is going to be pi over 2. And then, you know, half of that, which is 45 degrees, is going to be pi over 4 radians. So I guess, yeah. Okay, so let's talk about this next slide. It's okay. We mentioned that if we're talking about the proportion of the full circumference to the length of the radius of a circle, it's going to be always the same ratio. So the full circumference to the radius of a circle is always about 6.28, and that, well, that is exactly 2 pi, which equals to about to 6.28. But if we want to actually put it in the circumference in some units, um, let's say our radius is measured in centimeters, then we could calculate our circumference using this formula. It's circumference equals 2 pi r. Okay, 2 pi multiplied by r. So if you look at this formula right here and multiply both sides by r, that's how you're going to get this formula. Now some relationship of, you know, radians and degrees. So one rotation around around the circle, we know it's 360 degrees, and that it actually equals to 2 pi radians, or about 6.28. Now half a rotation is 180 degrees, equals 2 pi, and a quarter of rotation is 90 degrees, or pi over 2. As we mentioned before, we have some important angles that we're going to be talking about a lot, and 0, 90, 180, 270, 45, 135, 225, 315, and also 30, 60, 120, 150, 110, 240, 300 and 330. Those are our gonna be like very important angles. We actually will memorize the functions of those angles and be able to figure them out when needed. Okay, the associated radian measures are, we have 0, pi over 2, pi, 3 pi over 2. For the 1/8 of a circle, we have pi over 4, pi over 2, 3 pi over 4, pi, 4 pi over 3, 3 pi over 2, and 7 pi over 4. Okay, and we have associations with all the other ones. So 30 degrees is pi over 6, 60 degrees is pi over 3, and all the rest of them have that association too. Again, we are gonna, by the end of this course, you will remember all of these radian measures. Okay, so how do we operate with radian measure? Well, here's an example. It says find the radian measure of 1/3 of a full rotation. 1/3 of a full rotation. So what is 1/3 of a full rotation? That's our question. So we have x equals what is, right? What is x is equal sign 1/3 multiplied by a full rotation. The full rotation is 2 pi. So we have x equals 1/3 times 2 pi. X is when we convert 2 pi into a fraction, we're going to put 1 underneath. That's going to, and then multiply the numerator and denominator. We have 2 pi over 3. And that's our answer to this question. 1/3 of a full rotation is 2 pi over 3 in radian measure. Now I want you to pause the video here and try and answer this question by yourself. Find the radian measure of 3/4 of a full rotation. So please go ahead, pause the video here and find it. I'm gonna wait. And if you have any trouble finding it, let me know in class. So I assume that you already did that, you solved that problem. So let's move forward. And next problem, it says convert each radian measure to degrees. Okay, so in here, I want to remind you about unity fractions. Okay, those are fractions that convert some units into other units. Let's say centimeters to inches, or vice versa, or kilometers into miles. And not only measure, but we have weights like kilos to ounces and so forth. So the unit, like for example, if you know that 1 pound, for example, equals to 453 grams, then your unity fractions would be either 1 pound divided by 453 grams, or 453 grams divided by 1 pound. Both fractions equal to 1, right? Because we have equal equivalent weights on the top and on the bottom. So each fraction is 1. It's called the unity fraction. So if you will use this one if you want to convert grams into pounds. Why? Because whatever is on the bottom will be canceled out. So if you have grams here, they will be canceled out with grams on the bottom, and you will end up with pounds. But if you want to convert pounds into grams, so you have pounds here, you would multiply by a unity fraction, cancel, and leave with the grams. So whatever you want to have, the units that you are after, you want them to be in the numerator of your unity fraction. Okay, so here, let's apply it to our situation here. Here we're converting radian to degree. So, and we know that pi equals 180 degrees, right? So that's our units. The unity fractions would be either pi divided by 180 or 180 degrees divided by pi. So that's what we would use. Which one of these? Well, we are converting radians to degrees. So we want the degrees to be in the numerator. So we're gonna actually choose this unity fraction. So let's go ahead and do it. We have pi over 6 to start with, and we're gonna multiply by 180 over pi. And you see how pi's cancel out? The radians cancel out, rather. And we're going to have 180 degrees divided by 6, which will give us 30. Okay, so these are the unity fraction that you will use to convert radians to degrees. 180 divided by pi. For B, we don't have a pi. It's exactly 3 radians, so a little less than pi. But we're still gonna, to convert to degrees, we're gonna multiply by the same unity fraction. It's 180 over pi. Now, remember, if we're multiplying fractions, we have to convert out 3 into a fraction. So we're going to write it as 3 over 1. And what do we have? We have 3 times 180 divided by pi. So pi doesn't have units. 3 radians are unitless, because it's length divided by length of the arc divided by length of the radius. So units, it's unitless. So let's figure this out. So we have 3 multiplied by pi is actually a very famous number. It has, every scientific calculator has pi on it, so pi is right here. So what we do is 3 multiplied by 180 and divided by pi. I'm gonna push enter, and this is what we get. It is about, we're gonna round it, we're gonna round this number, 171.89 degrees. All right. And so I want you to try this one by yourself. Convert negative 3 pi over 4 radians to degrees. Okay, pause the video here, try it, and let me know how you did. And we're going to proceed with the last type of a problem that you're going to see in this section is converting degrees to radians. And okay, going back to our explanation, we're going to use this unity fraction this time around, pi divided by 180 degrees, because we have degrees here and we want to get rid of them. So we put 180 degrees on the bottom. We're going to divide by degrees. Okay, so pi, it goes into numerator. All right, so just like before, we turn it into fraction. And so degrees cancel out. And we're going to have 15 pi. Remember, radians are unitless. So over 1 times 80 is 180 is going to be 180. And all we need to do now is to put this into our calculator. So we're going to have 15 times pi divided by 180. And so the answer is 0.26 radians about. So approximately 0.26 radians. So Is it greater than half a circle or less than half a circle? Is it greater than a quarter of a circle or less than a quarter of a circle? What do you think? All right, so now the problem that I want you to try by yourself is this. Convert 126 degrees to radians. Okay, go ahead, pause the video just like before and try it by yourself. And I'm gonna see you in the next one.